Hello, I'm Mark, and welcome to part 2 of my Unreal Engine tutorials on how to add gimbal thrusters to your physics movement component. So this is a continuation of my vehicle simulation series, in which we're building a vehicle simulation component on top of our physics movement component. And in the last video, we went ahead and created all the components needed for our Gimbaled Thruster Setup. So we went ahead and added our mappings so that we could map both the throttle as well as the pitch, roll, and yaw. For our system, we created our physics gimbal input component here that will allow us to create the amount of vector we want for that thrust. And then we went ahead and created our physics gimbal thruster setup, which put all of that in there so we could create thrust vectoring through our gimbal system. And then we went ahead finally and integrated that into our vehicle simulation component. So today we're going to go ahead and test out this gimbal thruster setup, and I thought what would be the best way to show a gimbal system. And so I went out onto Fab and I found this Vigilant helicopter, this Blackhawk here, and went ahead and downloaded it. So we'll be using this to kind of set up our gimbal system. So we can create a helicopter using a gimbal on the main rotor, and we'll use the static for our tail rotor. So I will leave a link in the description below to where I found this. So if you're interested in following along, you'll be able to take this and follow along with me. Okay, so without further ado, let's get started. I'm just going to go ahead and close that. And we'll minimize Visual Studio since we won't need this. Since everything's going to be in the editor. So first off, let's go ahead and do a quick compile, make sure everything looks good. Alright, our solution is good. Alright, so let's get started. So the first thing we're going to do is we're going to want to make sure that we've got our input settings, our input mappings. So in the previous set of tutorials, we went ahead and worked with the drone. And the drone and I think the helicopter are going to have very similar inputs. I'm going to make one change. So what I'm going to do is I'm just going to go ahead and duplicate our IMC here. And I'm just going to duplicate. And instead of drone, I'm going to call this heli for helicopter. And I'm going to open this up. So here we've got our throttle input Z. What I'm going to do is I'm just going to go ahead and remove these inputs. And let's go ahead and bring that throttle Z back. And instead of using the data pad, I'm going to use the analog on the left side. So I'm just going to start up my pad, and Unreal Engine's going to notice that it's now connected. So my device is connected. I went ahead and clicked on the little keyboard up here. Now it's orange, so I'm going to press forward on the control that I want to use, and it's now mapped to my left thumbstick. So that's all I need to do there. And then the only thing I need to do here is just add our dead zone. Since this is an analog, we want to make sure that we've got some dead zone in there. Otherwise, even if our hands are off the controls, it could still be sending input into our system. All right, so that should be it for our heli. So I'm just going to keep this up. So the next thing, so if you're going to go with a Vigilant helicopter, once you've went on the site, downloaded it, and then imported it into your solution, you should see a folder like this. And in there, we should have vehicles, and then we'll have a folder for the helicopter. So as part of this is a skeletal mesh, and as part of the skeletal mesh, it's going to have this physics asset. So I'm going to want to make some changes here on our physics asset. So I'm going to go ahead and duplicate the physics, and I'm just going to put an underscore and type SIM to know that this is our simulation. So since we're going to be using this for simulated physics, we want to make some changes here. Originally this helicopter was probably used for animations and cinematics, and you could use it for using vector movement through the pawn movement component, but we want this for physics movement, so we have to make some changes. So to do that, I just duplicated that. I'm going to pop it open real quick. And I'm going to go ahead and remove the collision on the rotor blades, since it doesn't really work well for a physics movement. So I'm going to take the rear rotor and I'm just going to go ahead and delete that. I'm going to keep the wheel, and I'm just going to take the rotor joint and the rotor blades, and I'm just going to delete that too. Like I said, we want this for the animation, but now if you want to have collision on the rotor blades, then what you might want to do is, instead of using you could have the helicopter fuselage be a skeletal, right, as well as the wheels and the tires, but you'll probably then want to make the tail rotors statics, independent static objects, and then attach them within the blueprint versus using them here. And that would work just as well, and you'd still retain the collision properties for the helicopter when you're running it as a physics body. But for now, I just want the fuselage. I'm going to keep the tail fin right there, and everything else I'm just going to keep. So one thing I'm going to do is I'm going to select all of these for now, and I'm going to go into the constraints. So as you can see, I'm just right-clicking on the constraints, and I'm just going to adjust these. So I'm actually going to lock these constraints down. By doing this, if I was to bring this helicopter in without them locked and I put it on the ground, simulating physics, the undercarriage and even the tail rotor would look and feel like a wet noodle. So I'm just going to stiffen all of that up for this tutorial. But if you want to go ahead and play with it, I think you can get some. I think swing motion 2 is probably what you want, and you could probably set that to limit and then figure out where your limits are. For your wheels, you could probably go for free, but for the tail plane, you could probably use just a limited between 15 degrees. But I'm just going to lock everything down for now. Just keep it simple. And then the last thing I'm going to do is I'm just going to take the C-joint and everything else, and under here I'm going to come back to details, and under physics type here I'm going to move it to simulated. So we want to use this since we're going to be using this on a physics particle. Okay, so that should do it for that. And then let's go to the skeletal mesh, and under skeletal mesh we're going to just, under asset details, we're going to come down to physics, and here I'm just going to switch this over to use our new asset. So it's simulating physics. Alright, so that should do it for setting up the asset. So let's go ahead and build out our vehicle. So to do that, I'm just going to come up to movement, and I'm going to come into blueprints, and then I'm just going to right click in here and go to blueprints. I'm going to derive this off the pawn class, and it's just going to be BP underscore UH60A, which is the helicopter, and let's open that up. So for starters, this is going to be a skeletal, so let's go ahead and make it skeletal. So I'm going to find the skeletal mesh components, and I'm just going to drag and drop it so that it becomes the default scene component. And then under here, let's go ahead and find the Blackhawk. So there's our Blackhawk, and I'm going to be using the Blackhawk's animation blueprint. So there it is. So animation class is using the blueprint. The Blackhawk is there. Hit compile save, so the materials get brought in. And then the final things we want to do on setup is 1, simulate physics, so that we can use this on the physics particle. And as far as collisions, I'm going to set this to vehicle. And that's all I'm going to do there. Alright, so that should set up the helicopter with the all the assets we need. Just going to go and minimize some of this that we don't need to be working with. Alright, I don't think that there's really anything else here that we need. Okay, so let's now go ahead and set up the camera as well as some of the particle effects to kind of help bring this helicopter to life. So let's go ahead and add the camera in. So to do that, I'm going to add a spring arm. So there's our spring arm. And for the spring arm, to set this up, I'm first going to attach it to the center of gravity joint. So that is down here. So look for the COJ underscore GNT. That's the center of gravity joint. I'm then going to give it a length of 2000 so it can it's well behind the helicopter, and I'm also going to give it a height of 360, so it's above the helicopter. As far as the rotation control, I'm going to turn off pitch and roll. That way, when we're looking behind it, we can see the helicopter pitch, we can see it roll, but if we start yawing left and right, we want the camera to kind of move along that plane with the helicopter. But I'm also going to add some camera lag in there, so we'll add the lag. So as the helicopter gets faster, the camera will lag to catch up, and as we rotate the helicopter, especially left and right on the yaw, it'll lag a little bit there too, so that we can actually see the helicopter and it looks like it's rotating in front of us a little bit. And I'm just going to set that lag to 5, just 5 and 5. I think that works for me. And lastly, we have the spring arm, so let's go ahead and add that camera. So there's our camera. Attach that, compile, save, and I think we're good there. All right, so next, let's go ahead and set up the Niagara effects. So this, the nice thing about these assets are that it also comes with some nice little particle effects. So let's go ahead and use those. So under skeletal, I'm just going to say add and find Niagara particle system. And so the first thing I'm going to do is I'm going to set up the engine exhausts for right and left. So let's do that. I'm just going to copy this right now. And I'm just going to paste that name in there. So this is going to be the right exhaust. So I'm going to attach so this helicopter has some sockets for the exhausts. So right exhaust is going to go into the right exhaust system, and as you can see here we have the heli exhaust, so we're going to select that, save, and then all I'm going to do is I'm just going to duplicate this. So now we have a right and now we're going to have a left. I'm just going to go ahead and hit rename. So that's left exhaust, and the left exhaust, it's the same particle effect. We're just going to put it on the left socket. So now we have both left and right exhaust systems. And then the last thing is going to be the dust cloud. So for the dust cloud, we're just going to go and add another Niagara particle system. And that is going to be ground dust. All right, so I think that should do it. And so what's going to happen, and we don't need to attach this because we are going to be manually moving this ground dust and to keep it under the helicopter and turn it on and off when we need to do so. So we'll just keep that right there. So, all right, so that's our assets set up. So let's go ahead and bring in our vehicle component. So again, I'm going to come up to components, hit add, find our vehicle simulation component, and here it is. Here's all of our set stuff that we can start adding in there. We've already set it up so that we can add both air and water if we need to, and we will be using air. So let's go ahead and set this helicopter up. So first off, we're going to start with fluid dynamics. So under fluid, I'm going to go ahead and set the profile to use medium 1 out of the gate, and let's set a profile on medium 1. So again, this is in centimeters. So I went ahead and did some research to find the dimensions of the Blackhawk, and so I'm converting. So in doing so, I'm going to convert meters. So it's 2.4 meters wide, across, from side to side on the fuselage. So that would be 240 centimeters. So we're just making those conversions. And again, we'll do the same thing for the height. I'm going to set a drag coefficient of 2 and a lift coefficient of 1. Again, it just works for me. So when we're using lift, if we're moving in a forward direction, this is positive, it's going to actually lift us up. So this is going to help help us lift us up and give us a little bit of uplift as we're moving forward. Now, if we start moving back, it will have the opposite effect. It will actually give us a little bit of downforce. And I think that that's okay for a helicopter. So that's what we've done there. Let's get in the side profile as well, since a helicopter can move sideways. So these are the dimensions that I'm using for the side. So again, using 1554 for width, and I'm using 516 for height. Let me just make this a little bit bigger. And the drag coefficient, I'm going to set that to 4, and I'm going to set the lift coefficient to 0. So I want 0 lift on roll. I only want it on, forward. So sideways motion, we'll just keep it the same. And then as far as moving up and down, since we have this nice massive rotor, our surface width is going to be pretty large. So I'm using 1638 and I'm using 1554. Drag coefficient, I'm just going to use 4, and again lift coefficient is 0 because this is going in direction of the thrust. Alright, so compile and save, and that should do it for our fluid setup. So this is going to be our counter forces. This is the force of nature pushing back as we try and move through an atmosphere. Alright, so next, after that one, let's go ahead and set up our static thruster. And so I'm going to be using a static thruster for our tail rotor. So this is how we're going to move left and right, or kind of rotate left and right, I should say. So I'm going to call this tag name the tail rotor, and it is going to be taking in the yaw input control. So anything that's being passed in on set yaw, that's what we want to use. And then on direction, we want to move along the yaw axis. We're not going to use any offsets. I am going to negate it because our system is actually behind the center of gravity. So we want to make sure we get the opposite effect on the inputs coming in. And then as far as the thrust point, so Y negated. So the thrust point, I'm going to spend a little time talking about this, but let's go ahead and just grab it. So I'm going to be using, again, the central gravity. I found that in kind of working with this mesh, I found that this was probably one of the best setups that I was using to kind of control the helicopter. And so let's bring back the helicopter. So again, this helicopter was really meant for animations and not really was designed for physics movement. And I'm just adapting it. So, and because of that, and I say that because we've got this root joint right here. So if we've got this root joint, where the bottom of that root is, right, that is the 0, 0, 0. That's actually where the physics particle is going to attach to this helicopter. So some things to consider if you are working with an animation team and you want to use physics as far as physics vehicle movement, then what you want to do is you really want your center of gravity to actually be where that root bone, the bottom of that root bone is. So you don't need this root bone. And in doing so, what you'd end up seeing is something like this, right? And that's perfectly fine, because when we set this up as a physics body and we're using the physics assets, right, for collision, when it's on the ground, it will be sitting on those tires just fine. So it'll be sitting on the undercarriage. But we really want that COJ, right, to be where that's what we want, that to attach to the physics particle. And we also really want that central gravity to be where the central gravity of the helicopter is. So again, I think that this central gravity is a little too low. I'd probably bring it up a bit. And it's also, we would want this central gravity, the rotor blade, to be right on top of this central gravity, because I'm going to be using the rotor blade. And again, when I was working with this, I found that the rotor blade was kind of a little too far forward for the thrust. So again, we've got the offset so we can work around it. But again, just some things to think about if you're working with this. So I'm just going to go ahead and undo that real quick. All right, bring our helicopter back. So this 142, 143, that's the offset that I'm going to be using. So everything needs to just be offset by that and just be brought down, since the central gravity on this thing is too high, is about 142 to 143 units above the physics particle. All right, so that's kind of where we've set it up. So that's so I'm using 1,000 units off that, so it's going to be here, moving it back, and then I actually moved it up a little bit. And the reason why I wanted to move it up was, again, as I was doing some flight testing, I found that if I kept it out on the plane and I started moving it, there were some times where the helicopter would start to then pitch in, and if it, and at that point it would be too much of, it started to give me some really wicked negative pitch. And if you get too much negative pitch, then the thrust underneath the helicopter moves out from underneath the helicopter, and then your helicopter will go into an uncontrollable dive. So to do that, I moved, and that's probably why the Blackhawk has its rotor a little bit high as well. So what it's doing is it's actually going to give me a little bit of a roll in that yaw, and by rolling it and me putting in a little counter roll, right, it actually kept the kept me from going into a steep negative pitch. So that's kind of why I've got that there. Looks a little weird, but again, from flight, from playing with it, I found that for me that worked really well. But again, when you do you. If you feel that there's something a better setup that's working for you, by all means. And then the last thing, we need some thrust. So I'm just going to use I'm just going to use a static thruster 3000, and I'm just going to set a multiplier of 100. So I'm not going to use a static, I'm not going to use a thrust curve for this. You could, if you want to degrade the performance of your based on height. We will use a curve on the gimbal, but I'm not going to use it for static here. We'll just keep it like that for now. And then I'm just going to go ahead and, so that should do it for static. Let me just double check. Your y-axis negated. All right, that looks good. Time's still ticking. Okie dokie, so let's go ahead and set up the gimbal. So this is our new system, and this is really what we want to test out using the helicopter. So I'm just going to, this is going to be our main rotor. Enabled, I'm going to take the throttle from the z-axis, and we're going to move along the z-axis, so that's going to be up and down. So this is going to be the thrust that's going to be defying gravity. And rather than use rotation control to rotate the helicopter to vector that thrust, we're actually going to use input control and vector the thrust as if we're pitching the blades in order to create that thrust vector. So here, so we have pitch, roll, and yaw. Since we're going in the z direction, we don't need yaw. If we were doing, if you wanted to have thrust vectoring on a fighter jet and going in the x direction, you'd want to use pitch and yaw, depending on how you wanted that vector. Pitch would be pitch, yaw would be left and right, pitch would be up and down. If you just wanted pitch and without the yaw, then just use the pitch. Subsequently, you can just use yaw. But since it's a helicopter and we're going in a different axis, we actually want pitch and roll instead. So I'm going to set pitch to pitch, and I'm going to set roll to roll, little intuitive. And as far as the max angle, so this is going to be the maximum angle of pitch, and this is going to be the maximum angle of roll. So I'm going to actually set this to 3 on the pitch and 2 on the roll. And that should be it. We don't need to negate anything because our rotor is actually going to be above the center of gravity. Okay, so all right, so that should set us up there, and I don't think we need to make any additional updates. Nope. So now we need a location for our gimbal, And I'm actually going to be using for this one I actually went with the rotor, because that's kind of where I really wanted it to be. So if we come back to our helicopter and we look for our rotor, there it is. So we're going to put it right there at the bottom of the rotor bone. So, and then this is kind of why I say I think the center of gravity is a little low. It should technically come up a little bit. But then also you can see that that bone is actually forward, and that's why I think the center of gravity is not where it really needs to be. But again, we've got offsetting, so we can go ahead and tune that out. So first off, I'm going to go ahead and set the Z offset. So this will then bring this in proportion, in relationship to where the actual physics particle is. And then I'm also going to adjust the X location. So we don't need to worry about Y, but I'm going to bring it back a little bit, because when I put this right where it, again, this is where why I think the center of gravity is slightly off, is when I put it there, it was when I put it under the joint without it, the helicopter started pitching up and rotating back, and so I didn't want that. I just wanted the helicopter to come straight up. But again, it's up to you on how you want your characteristics to be. I'm just going to go ahead and save that real quick and compile, and I'll save again. Alright, so that's the location. So let's go ahead and assign the thrust. So there's a couple of ways we could do this. We could just go ahead and, once again, use a static value. But for this, I'm going to go ahead and just use a thrust curve instead, since we have the curve now. So to do that, I'm just going to open up the content drawer, and I'm going to just like we did for the drone, I'm going to right click, and I'm going to go to our miscellaneous, find our curve, float curve, hit select, give it a name. So I'm going to use FC heli thrust. Alright, and I'm just going to open this up. Hit save. So I'm just going to go ahead and add 2 keys for starters. Alright, so I'm going to create a start key and an end key. I think that's probably the best way to kind of set this up initially. So at sea level, which is 0, actually, that key is 0, 0. So at sea level, I want full power. And what I'm going to do is I'm going to say at here, I'm going to say at 15,000 units, I'm going to go to 16,000. So we're going to have a severe drop off there. And I'm just going to go ahead and just close that real quick and reopen it so it resets it. And so now let's go ahead and put some additional points in to create a curve. So let's go ahead and add a key. So I'm going to say it's 6,000 units here. I'm going to make this still 44. And then I'm going to add another key. And that key is going to be 96. I'm just going to say. And that one is going to be 41. So now we're going to start to see a power drop off between, and that will be between 6 and 9. So we'll start to see a power reduction. And then I'm going to put another key in. And that key is going to be at 12. And again, we will see a bit more of a steep power reduction. So we're now curving that out. And then I'm just going to put one last key in there. Realistically, we probably wouldn't get to here. And this will be at 13.7. And that is going to be at 26, which is probably not going to be even enough power to thrust to kind of defeat gravity. So there's our power curve. Again, you can go ahead and play with this and change it to your liking. but this is what's working for me. So I'm going to come back and let's go find that curve. So there's our heli thrust, and we're in. And so we're using the same multiplier. The same multiplier will be used for both the curve and the max. So it's all going to be multiplied by 100. All right, so that should do it for the curve. Let's come back to the helicopter. All right, so let me just do a quick check. So again, pitch is set up, roll is set up, nothing on yaw. We're on the right axis, taking the right inputs. We're at the right place. We have the curve with the multiplier, 100% condition. Okay, so that's our gimbal system set up. So now it's just, let's go ahead and set up our inputs. So first off, I'm electing to use some rotation control, but I'm not going to actually use rotate. I'm just going to use the torque damping in the rotation control. So I'm going to turn everything off. I'm going to turn this on, and I'm just going to put 0.8 for damp. And I'm adding a little damp just to make it a little bit easier on the player. Again, to take some of that workload off. You can elect to not even have this, and the helicopter will still fly fine. It's just going to take a little extra work from the player just to make sure to add in the counters to the pitch and the roll, where this will just help the player a little bit control that. So you can either use this system, or you can come in here and you can update the angular damp as well, and you can do it through angular damp instead. Up to you. I'm just using the system since we created it. So I'm just going to go ahead and minimize that. And then the last thing we're going to do is set up our throttle. So here, again, we're going to be throttling on the z-axis, so I'm just going to use the z-axis here. I'm going to set this value here to be 6, and I'm going to set this to be 1. I'm going to enable the throttle control, and I'm going to set this to 0.04, which is 4%, and I'm going to set this to 0.02. So rise rate is going to be 4%, fall rate is 2%, and as far as the interpolation, I'm just going to keep those even. And then as far as the pitch and the roll inputs, I'm just going to make this a 2-to-1 ratio on the rise and the fall. All right, and I think that should set everything else up there. Okay, cool. So that should, I think, do it for setting up our movement control system. So let's now go ahead and come into the event graph and then start putting all the other pieces in so we can actually make this helicopter fly. So to do that, first thing we're going to do is we need to map our input mapping context. So I'm just going to come up here. I'm going to go find our event receive controller change. There it is. So this fires every time the controller gets updated within the class. So if you were creating a game in which your character wanted to take possession of a vehicle, right? Then this event will fire when your controller takes possession of that vehicle, and this gets fired even on begin play. So it will check to see which controller it is, and so it's, at that point you're adding a controller, which means it's going to do its thing. So that's why we're going to do it up here instead of on. That's why we're going to do the context mapping here instead of on begin play. So here I'm just going to say cast to. So we're going to cast this to the player controller because that's the controller. If this is a player controller, this is what we want it to do. We're then going to say, look for the enhanced input. There it is, get enhanced input. There's our subsystem. And then off here, I'm actually going to do a isValid. This is just something that I noticed when I was working with the networking. And sometimes this could fire multiple times, and sometimes when it would fire, if I didn't do an is valid first, this system might not be set up yet, and you'd get an error in your blueprint. So to make sure that when this gets fired correctly, and we do this at the correct time this gets fired, because this will be fired once, maybe multiple times between a client and server. So again, I just found that just adding that in there helps. But what we really want to do here is we want to do the add mapping context. So here's our add mapping context. I'm just going to go ahead and drag that and drop that into there. And the context we want is our helicopter map. And that's all we need to do there. So the only other thing I'm going to do here is on control, as soon as our pawn takes control of the helicopter, I'm actually going to go ahead and say load current vehicle state, and I'm just going to go split this value. And just like with the drone, I'm actually going to put in a power setting on the Z value of 0.65. So we're automatically going to start our helicopter with 65% power on the rotor. Since a helicopter really only uses the top 10 to 20%, everything else is considered trying to fight gravity. So we're just going to start there. Alright, so that is going to be our input mapping. So what we can do is we can highlight it all, hit C, and in the comments say input mappings. So that's there, that's all together. I'll just put that up there. Alright, so next we want the begin play event. So let's go ahead and bring this up. And on begin play, we're going to do a couple of things. Since we're using a skeletal mesh and it has an animation blueprint, we want to use the animation blueprint to drive the rotor. Since it's already there, let's just take advantage of that. So I'm just going to grab the skeletal mesh, and then I'm just going to say get anim instance. So this is going to get the instance of the animation blueprint that is being used. And I'm just going to then do a cast to a EP, and there's our helicopter animation blueprint. So the first thing we're going to do here is we're just going to go ahead and grab this, and then I'm just going to say promote this to a variable, since we just want we want to have access to the animation blueprint. And I'm just going to go ahead and shorten this up. Just going to call it anim instance for animation instance. All right, and then after that, we're going to need a HUD so we can see flight data. So to do that, I'm going to say get. So I'm going to say get controller, and the reason why I want to do this is that I want to only show this HUD if this vehicle is being controlled by a player. So then I'm going to say cast to player controller, because only this HUD should only be on here if the player controller is the primary player controller. So I'm going to do that. So if it's a good cast, then I'm going to say create widget. There it is, create widget. And I'm going to make the controller the owning controller. So the widget I'm going to create is I'm going to repurpose the drone HUD. But we've got a little bit of a problem with the drone HUD, and we'll correct that just after we've just added it to the viewport. So I'm going to say add to viewport. So this is going to create an instance of this HUD, and it's going to add it to the viewport. So we created this drone HUD, and it's got all the information we want. The only downside is that this HUD is actually referencing the actual drone. But so what we can do is we can make it so that the animation, both the drone and the helicopter can use the same HUD. And to do that, probably the best way to do that is through an interface. So what I'm going to do is I'm going to go into the UI folder where our HUD is, and I'm going to right click and I'm going to go to blueprints. If you haven't used these, so they work the same way as if you were in C++ and creating an interface that way. So we're going to create a blueprint interface, and I'm going to call it BPI. What am I going to call this? Going to call it Heli HUD maybe. And this interface is going to have two functions. So just like a regular interface, it's just there's no implementation, it's just definition. So let me pull up this. So the first function is going to be get actor. And the second function is going to be get simulation components. And that's all I'm going to do. So get actor, if I click on get actor, we just need to have an output. So let's define an output of actor, and let's go find that. So this is going to be under act. There it is, there's actor type. So that's what it's going to return. So hit compile, save. There it is. And then get simulation component. It's going to do the same thing. Component. And instead of an actor, this is going to return our vehicle simulation component as a reference. All right, so now that we've got our HUD defined, or our HUD interface defined, we just need to add this to the things that are going to be using it. So I'm just going to go ahead and add it to the helicopter, but you probably, once you've made all the changes to the HUD, you'll probably just need to do the same thing on your drone if you want to use it for the drone again. So under here, under class defaults, so we're going to highlight that. Actually, no, class settings, my mistake. So under class settings, we're going to come under interface here, and then we have implements interface, and we're going to go add, and then we're going to find BPI, and there it is, BPI HUD Heli, and that should add it. And when it does, it's going to, over on the left hand side, it's going to create two functions for us. So if we go in here, I'm just going to click on get actor, and I'm just going to drag off here and say self. So we just want a reference to ourselves coming out here. And then on the component, I'm just going to drag this guy and hook it up there. And that's the component. And that's all we need to do for the interface and hooking that in. So now we've got an interface, a common interface, and that's how we're going to determine where, when to, that's how we're going to allow the interface, or the HUD, right, to pull in the components. So let's go ahead and find our HUD. So this is our drone HUD, and we're going to go ahead and convert it over. So to do that, all we need to do is, instead of casting to this and using that, I'm just going to go ahead and say cast to BPI. So we're going to, instead, I'm going to cast to the interface. And what this does is it's going to say if this is a good cast, if this pawn here is implementing our interface, then we can go ahead and run the two functions on it. So the first one's going to be get component, And then the second one, and here I'm just going to go ahead, drag and promote to variable. So there's our component. And then off here I'm going to say get actor. Just put a little reroute node there. And do the same thing. I'm just going to go ahead and say promote to variable. There's our actor. Okay, so I'm just going to go ahead and save. So a quick way for me to do this, I'm just going to come in and I'm just going to remove this. So I'm just going to say delete. I'm going to say yes. And as soon as I hit compile, I'm going to get a whole bunch of errors. So all I'm going to do is I'm just going to go and click on these errors, and this is going to take me to what I need to be finding. So here is the component. So I'm going to say get component. Make sure it's valid. Put it there, and I can take that out. Again, this is a component, so do that. It's just a quick way for me to find all the issues. So I just deleted the original reference to the drone. Instead, I'm just referencing the individual components. Here is the actor, so I'm just going to grab the actor. Again, make sure we're valid first before we try and use it. Again, the actor. Again, the actor. A lot of places. And this is the component. We're back to component again. Get components. Again, just hook these in, just replacing them real quick. And so this will allow us to create reusability on the HUD between two different vehicles. All right, so everything else is compiled out now. Everything looks good, so our HUD should be good enough to go for the helicopter. And then if you wanted to go back to the drone, or you just have to do the same thing you did for the helicopter, go to class settings, add the interface, and then just go on ahead and hook up the actor and the component. Just fill out these two functions right here on the interface, and again, everything should work. All right, so that's the drone HUD, that's the interface, that's the heli. Let's get back to the helicopter. I'm just going to go close these two tabs and get us back to the event graph. All right, so now we've got begin play, we've got our context mappings. So the next thing I want to do, we don't need overlap, so I'm just going to remove that. So I think the next thing I want to do is on tick, and on tick is really going to be how we're going to be running the effects. So let's go ahead and set all that up next, I should say. So these are all going to be done off some custom events. So the first thing I'm going to do is the exhaust fumes. So let's go ahead and do that. I'm going to say add custom event, and I'm going to say set zoom in a little bit. So set exhaust fumes. So to do that, I'm just going to go ahead and just drag out our right exhaust. I'm going to say set active There it is. So this is going to tell us when we want to when we want it to be active. And actually, before we get go that far. On the exhaust fumes, I'm just going to add a parameter, and this is going to be a float parameter, and this is just going to be intensity. And this intensity is going to be mapped to the amount of throttle we're adding to our helicopter. So we just added that. So what we're going to do is I'm going to set this to active. So I've got the right exhaust, and I'm just going to go grab the left exhaust as well, and I'm just going to put that into the same. So in blueprints we can go ahead and just, you know, short it like that. So putting two into one node. And then on active, if we want to know if it's active or not, we're just going to do a quick little condition check to see if it's greater than. If it's greater than, it's active. If it's less than, it isn't. Or there's just not enough intensity for it to be coming out the back of the engine. So I'm going to set that to 0.5. And so then the next thing after this is we want to go ahead and set the Niagara variables. So to do that, I'm just going to pull off one of these. And this one's using a string, so I'm just going to go ahead and do this. And again, I'm just going to do both right and left, hook both of those in. And as far as the value is concerned, I'm just going to pull this down. We're just going to do a multiply, so just find the multiply operation, and I'm going to plug that in, and I'm just going to multiply it by 3. So again, this is going to set the intensity of the plume, and the variable in that Niagara component is called spawn rate. So what this is going to do is it's going to go in there and it's going to look up this variable by its string name, and then when it finds it, it's then going to go ahead and assign it. And so it'll do. We want to do this on every tick in the game thread. So that's setting up the exhaust. So the next thing we want to do is set up our dust plume. So to do the dust plume, all I'm going to do is I'm going to say add custom event, and we're going to say set dust plume. And again, I'm just going to take intensity. I'm just going to copy this. So we're just going to add the intensity again and float. So the intensity is going to determine how much dust is going to be the intensity of the dust being generated. But we also want to know where we want to locate that dust plume under the helicopter. So there's a couple of things we're going to do there. So first off, let's go ahead and add a variable to be able to turn this on and off. So I'm going to say, I'm going to add a Boolean variable under variables. So this is going to be is near ground. I'm just going to pull it off and hit get. And then I'm just going to go drag our dust plume. And I'm just going to drag this. And I'm going to say set active. So this will, again, this will help to turn, this will turn the dust plume on and off if we are near the ground. And so I'm just going to put that there and that there. And then what we need is the intensity of the dust plume. So I'm just going to drag this off. I'm going to set I'm going to use set Niagara float for this one. I'm just looking at my other solution. So with that one, I think it does the same thing. It's just one takes in a string, one just takes in a name instead. And again, we want the intensity, so I'm just going to multiply the value coming in, and this one's going to be multiplied by 200. All right, so if we're in position, then this will turn it on, and we'll, based on the intensity of the the rotor blades, that will determine how much dust is going to be washed out underneath the helicopter. Now, what we need is to know, one, are we within range to turn this on or off, and two, we need to know where it is. So to do that, I'm just going to create another little custom event, which will use a line trace to see where we are. So I'm just going to say add custom events. I'm going to call it ground test. All right, so underground test, I'm just going to go ahead and first get the actor. And specifically the actor location. And we're going to need this, and then all we need is the down trace. So I am going to then say, I'm going to do two things. I'm going to do an add, and I'm also going to do an, I suppose I could do a subtract here. So this is going to be where I'm going to start, this is going to be where I'm going to end. So if we come back to the helicopter rate, if we go back to our root is at this is where the particle physics particle is. But I don't necessarily want to start the trace there, because that could technically be in the ground, but we still want the thing to be flying around. So I'm going to lift it above the ground by about 50 units. So let's go ahead and do that. So here I'm going to put a plus 50. So I'm going to take the actor location and add 50. And then here I'm going to go ahead and subtract 800. So that's the length of the line trace that I want to do. So here I'm now going to pull off here and say line trace, and I'm just going to do a line trace by channel, so keep it easy, simple. I'm just going to go ahead and put the start in there. I'm going to go put the end in here. I don't need to, I don't want to rotate this, right? So we don't need to rotate this by the actor's rotation. We just want a straight trace down off that position. And so this is just gonna, this is kind of, so we have the altitude that we're getting, but that's from sea level, right? But what we want is the ground clearance, and so that's what we're going to be marking here. And so I'm going to be using the visibility channel. Don't need to worry about complexity. We're going to ignore self, and I'm not going to draw this out. We should just be able to see it. We don't need to worry about debugging. All right, so once that's done, if we get a return, i.e. if that trace goes down and it hits something, then I'm going to do a branch. And we're going to go and pull out our near ground variable. I'm going to set, and I'm going to set. So if true, we're going to make this true. If we don't hit anything, i.e. we're in the air and there's nothing underneath, it's going to be false. And then on hit, I'm just going to pull this out, and I'm just going to break the hit results. And I'm going to go with the impact points, and I'm going to pull this out, and I'm going to say promote to variable. So if we hit, we will also want the impact points of where we hit. And that's the only thing they need out of there for this. All right, so that's our collision. And then when we come back up to our dust plume, we're going to do one more thing and off the dust cloud. So I'm just going to pull this off, and I'm just going to say set world location. And that wood location is going to be using our impact point here. So I'm just going to connect that into there. So that should put our dust plume, whoops, where we need to put it. All right, so now I'm just going to come back to our tick event. Going to move that up there. Just going to move this over a little bit. So under the tick event, we're going to do multiple things. So I'm going to add another custom event, which is going to be our run effects event. So actually I'm just going to put this down here. So I'm going to say add custom event. Run effects. So this will be our visual. This is going to run all of our effects, including our animations. So off here, and then again, I'm going to add another float. So this is going to be our this is going to be taking our throttle setting in, and we'll be using that to manage all of this. So, all right, so first off, I'm going to go grab our animation instance. And I'm just going to say get, and I'm first going to say is valid. Just to make sure that our animation instance is valid before we use it. And then let's go ahead and use, so this is the reason why I wanted to use the animation instance. So within the animation instance, there are actually some functions, and I can actually bring this up. So if I come into the vehicles, 60, and we'll come into the animation instance. Right, so this is the animation graph, but if we go to the event graph, there's actually some public functions that we can use, that we will use. And those functions, so it's got a lot of, you can update the windows, you can update you can do a lot of cool things on the animations for the doors, but there's also updating the rotor speed. So there's the rotor speed and there's the main rotor. So what we want to do is we want to update the rotor, main rotor speed and the tail rotor speed. And there should be a function that's in here that allows us to do that. I think it's... Yep, there it is. Set main rotor speed and set tail rotor speed. So there's actually functions here and here that have been included. So these are the two functions that we're going to be using in there. And they're public functions, so we'll be accessing that to set this variable in the blueprint, and we're going to be doing that from here. So let's go ahead and pull this off and find the set main rotor speed. So there's set main rotor speed, and so I'm just going to go ahead and take the throttle setting and put it in there. And I'm just going to put a reroute node. I'll put one there, and I'm just going to put, whoops, come on, little fiddly. I'm going to put one there. And then off here, so that's the main rotor, so we also want the tail rotor. So there's the tail rotor speed. And again, I'm just going to go ahead and drag, add a reroute node, since we'll be using the same throttle variable for nearly everything here. All right, next we're going to do the, after we've set the rotor speed in the animation, let's go ahead and set the exhaust fumes. So I'm going to say set exhaust fumes. So there's our custom event there. And again, let's just put that in there, hook that up, Again, just using the same value. Then after exhaust fumes, we're going to need to run the trace before we actually go ahead and set the dust plumes. So I'm going to say ground test. So we'll run the ground test. And then after that, we will then set dust plume. And again, we'll just grab this, drag that over there, and I'll just put a little reroute node to keep it nice and clean. And that should be everything for the effects. So then all we need to do is we just need to come into our event tick. And I'm just going to go ahead and pull off the vehicle simulation component, and let's go to our get current vehicle state. So this is our little constant function to get the vehicle state. And I'm just going to go ahead and split this. So this is all the data that we can pull out and read from the vehicle simulation component as it's simulating. And what I'm going to do is I'm just going to drag this and I'm going to say run effects. And we want the Z throttle since we're running off the Z throttle. Okay, so that should set up all of our effects. So the only thing we have left to do is really the inputs. So just like with the drone, let's go ahead and get those mappings. So the first thing I'm going to do is I'm going to say AI underscore IA underscore throttle input Z, since we're going to be using Z. So throttle input Z is there. That's what's in the mapping. So that's what we're going to be taking in and using. And I'm just going to grab our simulation component, drag off here, and I'm going to say set throttle. Let's just connect the nodes. I'm going to go ahead and connect the action value, and then just make sure that you set it to throttle axis Z on your enumerator. So this is here, it's going to come in here, and we want this value to keep mapping into the Z input because that's what we're going to be using for our up thrust. Alright, so then we have IA underscore pitch. So this is our pitch input, and this is going to map to our vehicle simulation set pitch. There it is, set pitch. Hit save, and then we're going to say IA underscore pitch roll. So here's our roll input. Again, I'm just going to go grab this, drag, set roll. There's our set roll function. Maps in there, and then the last one is going to be IA yaw. Okay, and let's map this to yaw. Drag that in there. Connect the dots. Oop. Alright, so that should be all of our inputs mapped in to our control. We've got all of our other things in there, so okay, that looks good. I don't think that there's anything in the constructor I need, so I think we're good. So let's go ahead and find a nice big map, and let's see if we can take this out for a test drive. So let's go to our map folder. I'm going to pick wide open spaces, which is what we've been using. And let's go ahead. I'm just going to move this off screen real quick. And go into the content drawer again, go to movement blueprints. There's our helicopter. Just going to drag it, drop it, give it a little bit. All right, so because we've been using this before, I just want to make sure that under details that we've disabled the auto possess on our drone. And I'm just going to go ahead and set this to player 0, which is player 1. Alright, so if we've done everything correct, so we should be able to start. So I'm just going to go grab my controller, power it up real quick. Alright, it's connected, so let's go ahead and hit the play button and see what happens. Alright, so there it is. It's all started up. We've got dust plumes. We should have some heat exhaust coming out. Yep, there's a heat exhaust too. There's a little distortion there. So let's go ahead and power up. The HUD looks to be working, so let's go ahead and add the power. And there we're rising. Up. All right, so we got one little issue. We're pulling back a little bit. So looks like our pitch needs to be negated, so let's go ahead and do that. Let me just check the roll real quick. So roll looks to be okay. It just seems like our pitch needs to be reversed. And how's our yaw? Our yaw looks okay. So it's just our pitch. So I'm just going to stop this real quick. So we can do this in two places. We can either do this in the... We can either negate the input controls here by adding a modifier, right? So we actually have two modifiers here. So we already have a negate here. So I'm actually going to take this modifier out. So I'm just going to say delete. So we'll keep the dead zone, but we've got the modifier. Do we have a modifier under roll? Oh, just a dead zone. So we already had a negate there. I'm taking the negate out. So let's give it another test. So I'm just going to go ahead and hit play. There's our helicopter. Let's power up. So we've got lots of dust flying around. Heat's coming out of the fumes. I'm going to pitch her over, and there she goes. And now we're flying. Going to take some of the collective out. Going to pull back on the pitch a little bit. And now our helicopter is flying using our gimbal system. Trying to keep the pitch angle relatively shallow. But as you can see, our helicopter, unlike with the drone, where we would really have to pitch the helicopter or pitch the drone in order to kind of get that thrust vectoring here, it actually looks like we've got almost level flight, which is kind of what you'd normally expect with a helicopter, and that's because we're able to vector the thrust underneath the helicopter by pitching the blades. And the reason why the helicopter again is pitching over a little bit and has some negative pitch and then and rolling is not because we're rolling the chassis. It's actually an indirect force torque being added from the actual vectoring the thrust. So, and because we're vectoring the thrust above the center of gravity, our helicopter is torquing based on that. And it's the same thing with the using the yaw controls. Yeah, needs to add some thrust underneath there. Kind of take that out a little bit. But yeah, there you go. We've got a thrust vectoring under our helicopter using all of the systems that we've kind of put together so far in our vehicle control. And as you can see right now, one of the things, you might see is that if I power up right, it looks like the blades are stuttering. And that's really more the camera and the camera frame. So again, this would be some things you might want to work out with if you're working with an animation team. to kind of, again, this is why I'd probably say you might want to use static blades for helicopters versus skeletal. But apart from that, everything looks pretty good. And then as we start to come back down again, you can see our drones hovering over there. I'm going to try and get some more positive angle. And then the dust plume comes up underneath to give us a visual indication of, we're close to the ground. Okay, so I'm just going to go ahead and stop this video. So again, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. And I will see you again in the next video. Cheers. Bye.